SwayamPrabha. Digital India. Educated India.
Welcome to today's lecture. We just saw the way that mineral deposits are discovered, and in the last two case studies it was quite clear that data generated from various techniques need to be synthesized, need to be studied together for any successful exploration program. Today we will discuss something which will be only in that line, and this the topic, which is essentially goes by the name as mineral potential mapping. The intention here is that there is some introduction to this concept should be given without getting into the much details of the much into the procedural details or the implementation through software, but it would, since the mineral exploration today is very much dependent on analysis of huge information gathered from all possible sources, geology, geophysics and geochemistry, and there is the demand, or there is a need for better and better methodologies for synthesis of the data. And essentially what one would like to have as a geologist, we always deal with maps. There are different types of maps, like a lithological map or a structural map, or the kind of magnetic anomaly map, gravity anomaly map. All these things we have already seen, and they are all in reference to a specific area, a space. So they are essentially data in space, and what essentially we would like to have also a map which would indicate areas where there would be where we could possibly indicate, or we could demarcate, or through any of our coding, that those areas are indicated to be highest probable or the most potential areas, and that is why the concept this is known as a mineral potential mapping. Means at the end product of it, one would always like to see a map where areas with the highest probability of occurrence of ore deposit could be identified, and such areas which in the actual case studies where you saw some data acquired by some specific methods, we actually target for that. We always try to, in the process of exclusion, select out areas which should be more potential, and so that more intense ground exploration work could be carried out. So the intention here is also the same. So it can be called as a computerized mineral resource appraisal, and we will be restricting to only the very basic idea about this concept, although it requires familiarity with geographic information system, but this discussion would be made in a way that there would be no need to get into the fundamentals, but geographic information system as a tool is essentially very important, very essential in any kind of work which involves mapping and analysis of data which are essentially acquired with respect to space, because whenever we talk about a geochemical anomaly, we do talk about sampling points. Whenever we talk of any aeromagnetic map, it is with respect to a particular area bound by the latitude and longitude, and every point of sampling is known, that at what interval the data is taken. So they are essentially data in space. So what generally we think about, or the process that we should be doing with them, is essentially the spatial data to model the spatial data. This example is intentionally taken because, say this is an area which is mineralized area, and this black part is shown as the ore deposit, and the ore deposit is surrounded by hydrothermally altered country rock, and there are different types of lithology. There are some tuffs, there are post ore volcanic rocks, and they are covered with alluvium. So, if this is an area which is which shows mineralization and associated feature, then it should be how we can suppose this area is studied by remote sensing, by taking the digital image data in different bands that we discussed, and suppose we are considering the thematic mapper which has got 7 bands which we discussed before, and these colored pictures are the end products of analysis of the digital data using various techniques. We discussed about the taking a ratio of the band 3 to band 1 to bring out the iron oxide species, or band 5 to band 7 to bring out the altered the clay mineral species 5 by 7, and there are some methodologies, typically digital image analysis methodology, which even can, suppose for example, this is a 5 by 7 ratio image, and this is an image where a little bit more of improvement technique has been used. So, what we could see here, that the area, that mineralized area is, which is also this, it is definitely bound by definite spatial coordinates, spatial limits, and every point within this is also spatially known. It is spatially referenced in terms of, we might say, in terms of pixel, and referring to a particular coordinate in terms of latitude and longitude. So, this is also, since we have got some idea about a digital image and representing its ground resolution in terms of the pixel could be of, depending on what is the satellite, as we saw in case of a TM or the thematic mapper, the pixel could be a 30 meter to 30 meter resolution. So, within that we are basically acquiring the data. So, this also can be thought of as the data which is a spatial data referring to the smallest ground resolution unit, and then it is compiled in a map. So, this also is a map. So, a mineral potential map is a map where the probability of occurrence of mineral deposits is portrayed with a reference to a particular area. We all understand probability. So, means which is a parameter, a probability can take a value from 0 to 1. So, if we say probability is 0, means we can say that this deposit is never to be found there, which is theoretically generally a value of 0 is not given, and a probability of 1 means a deposit has to is certain to be there. And when we see in terms of the mineral exploration and synthesizing of the information in finally producing in form of a mineral potential map, we can see the value of the probability, what kind of value does it take. So, it is a synthesis of all already available information on all possible geological, geophysical and geochemical attributes to assess the mineral potentials of an area or region. So, here it will not be very difficult to understand that we know that geological data is subjective data, because in geological data we plot a geological map or we indicate the structural patterns in terms of the presence of or the foliation, the data of the foliation or the fold axis or the axial planar features or fracture density. So, many things we can present on a geological map. So, from the previous example that I gave about a satellite image data being produced as a map, where every pixel has got some value, known value in terms of number. Similarly, a geological map, if it could be converted also into an object, where also within a confine of a definite spatial coordinate, every point could be represented with some numerical value. Geophysical anomaly values are in any case coming as numbers, they could be used. Geochemical attributes are also in terms of geochemical anomaly, in terms of concentration ppm or ppb of any of the metal of interest, which are also as numerical data. they can be assessed, and we need to have a methodology where all these types of data corresponding to the same space, same space bound by the geographical coordinate could be synthesized. And essentially one thing is also important to mention here, that this mineral potential mapping exercise is essentially, it could come very much under the brownfield exploration category, where we need to have some information about the area where there is a mineral deposit or an ore body is existing, so that we could associate the existence of that ore body with all other attributes such as geological, geophysical or geochemical, and this should be something like, it will be independent of any genetic hypothesis being known for that particular deposit or known, because out of the available geological elements, all of them may not be a part of the mineral on the origin or the genetic model that we have built up for the origin and evolution of that particular deposit. So, it involves integration of spatial data using appropriate algorithm, and it needs a computer. There are many methods, I will not be going into all of them. There are some simple methods like a weight of evidence, means it is the self explanatory that we will be taking something as evidence in favor of occurrence of a mineral deposit. That is an event which is, so that evidence could be all the geological, geophysical and geochemical data that we are talking about, and here it will only be this method is that we take some evidence and then come out with some inference in terms of probability. The other one is logistic regression, where if we know what the normal regression is, in a normal regression a dependent variable like y is fit to be a function of an independent variable x, one independent variable x or more than one independent variable x1, x2 up to xm, where in a normal regression we take the dependent variable as attaining any numerical value, but in case of the logistic regression the value that the independent variable can take is either 0 or 1. Means 0 would correspond to the situation where the deposit or the feature that we are looking for, in our case it is an ore body, is absent, or the situation could be that ore body is present, and this, if this is our y, then this y is being visualized or can be fit to be a function, this y to be the function of x, where this x could be representing all the attributes, all the geological elements or whatever data will be there which you could quantify. And I would not go into any of the details of this methodology. This can be later on learned, and this will provide us with bit of interest to go and see what is happening in mineral exploration, just other than confining ourselves to just see. The purpose being that we would also have some of the things in the agenda to learn them and to know what exactly it is. So, the materials are a lithological map or a geochemical anomaly map, a structural map, satellite digital image with all sorts of processing, come out with the alteration map or presence of alteration zones and so on, a geophysical anomaly map. So, it is a situation where I will come to this training point theme what it is. So, we propose in this particular methodology, which is the weight of evidence, means we will take some evidence as providing the evidence for the presence of what we are looking for as a mineral deposit. So, whatever we will be preparing in terms of the information will be called as the evidential theme, and here the evidential theme also could be presented in terms of present or absent, that means the value could be 0 or 1. Even if we do not get into that now, they are evidence. So, for example, a structural map could be one theme of information or one layer of information, or a geological lithological map, the presence of that particular lithology in particular selected areas, and then this training point theme will be essentially the points in space where we know that the deposit is occurring, and that is why we say that it is from known to unknown. This is from known to unknown, means we know that a particular deposit, as we will be cutting into the discussion, it will be clear. We know that a deposit or an ore body is present in a point in space on the surface, on the earth or surface or subsurface, then a deposit is present, and that deposit, that particular point is having all other attributes in terms of the geological, geophysical and geochemical, and now we are going to associate this feature being present with all the other attributes that are observable there, and we will be analyzing them with this methodology, that and then produce something which is called a map where the probabilities will be indicated, and we will call it as a posterior probability. This example gives, suppose this is the rectangular part which is shown here is the region, and out of which this part is the study area, and in this study area suppose these white dots 1, 2, 3, 4, 5, 6, these 6 dots are the points where the ore deposit is known to be present. And now since we have an idea of the ground resolution and pixel or resolution element pixel, or so we know that we can divide this whole area of interest into innumerable number of such divisions, each representing each division is one element, and that division of that element could always be characterized whether this particular deposit which is present in that. I can possibly give a bit of an idea here. Suppose I will just draw lines like this. So, out of which I can say that this white dot is present in this pixel, this pixel, this pixel, this pixel, this pixel and this pixel, and rest of the other pixels are where the deposit is not present. So, that means I can think of that this a parameter which is called a prior probability by dividing the probability occurrence of a deposit as the number of points on which the deposit is occurring divided with the total number of such. Suppose there are 1000 squares here, out of the 1000 squares 6 squares has this mineral deposit, that means the probability can be expressed as 6 by 1000. So, which will be something like 0.0015 or something like that. And so, this gives me an idea that what is the probability if I take this area of interest, what is the probability that any point would contain an ore body, which is now. So, there are situations will come, so that all these pixels are also having the geological, geophysical and geochemical attributes. Now, think of that this particular point where the deposit is occurring, other situations will be that the deposit is non-occurring, whether the features would be occurring, or there are situations where the deposit would be occurring, but the features would not be occurring, and the other fourth situation is that the deposit is not occurring or the feature of interest, any geological or geophysical or geochemical, is also not occurring. So, it will give rise to concepts of some positive weights or some positive weights here, or some negative weights. Means positive weights means all these cases where a deposit is occurring and all these cases where the deposit is not occurring, and it will give me some numerical value that I could assign by combining these positive or the negative weights, and each would be with respect to that particular resolution element or the smallest area that I am dividing it into and considering that to be a point. So, here this positions or the coordinates of these points which are occurring here are the can be considered as making up an information layer or an information where these coordinates are identified as the deposit or the feature being present, and that will be that we will consider, or that is being called or being termed as the training point. And then what we generally do, so these are the weights, and not getting into the mathematical details, by simple methods of conditional probability and calculation of posterior probability, we calculate what is the probability of occurrence of a particular what is the probability of occurrence of an ore body at any point of interest in the whole area, so that we could also join them in terms of contour, or you can put them into some categories and produce something called a posterior probability map. So, this example has been taken from the published data of Natural Resource Canada. This is the example of a study area, and the black dots are representing the locations or the points where gold deposits are occurring. Let us see. So, what we mean by such evidential themes, or what are the evidence that we are actually taking. So, this is in this particular study area, what is demarcated in purple color corresponds to the formation of corresponds to the presence of a particular rock type. Let us say it is Greenville formation, Golden Well formation. It could be anywhere in any geological terrain where such situations could be existing. So, suppose one particular information. So, here we could see the situation that we are talking about, presence of this particular ore body, particular geological unit, and presence of ore body. So, situations are there that the ore body is occurring where the rock is present, the ore body is occurring where the rock is not present, the ore body is not occurring where the feature is present, or the ore body is not occurring where the feature is also not present. So, those four probable possibilities are coming out very clearly when we are seeing such a study area where the locations of the deposit are shown and in relation to the presence of a particular rock type. Similarly, if we have done the structural analysis of the area, then these are the regions in which we could trace out the lineaments, and what is shown as thick lines is a concept which we used as a proximity. Means, for example, if there is a this is the linear feature, whether a mineral, whether an ore body is lying either very close to it or very far off it. So, we can think in terms of an influence of that particular element, which is a structural element, in relation to its spatial association with the occurrence of the ore body, which we call as a buffer. I may not, it's just for your knowledge, but it does not require to be understood right now. It could always be understood in terms of what spatial distance away or within from that particular geological feature the ore body is occurring. Similarly, this is the plot of the anticlinal axis that is studied here, and with respect to that also the how the ore deposits, ore bodies are, the ore body points are fixed, only we are showing the other geological features. This is a biogeochemical anomaly map, and combining all these together, what is produced here is a map which looks like this is the mineral potential map of the region, where the probabilities are scaled from very low value, very low values of 0.000347 to coming to 0.03 to 0.1. So, 0.1 necessarily means that it is about 0.11. So, that means just about 11% in terms of the probability. And as we discussed before, the mineral exploration is essentially a very high risk economic activity, and here the success rate is actually very low, and that what basically is coming out from here, even such kind of a low values, what is shown as probability, but still. So, what we are seeing in this map here, that all those areas which are shown as very high probability of going up to 11% are already also containing the deposits, like situations here we could see that it is containing the deposit, and many other situations where the high probability areas already are showing the deposit to be present. So, that gives us a kind of a validation of our procedure, even though it could still be having some errors here and there which could be further be rectified. For example, even deposit occurring in an area which is within a lower probability, and then what is more interesting is that there are areas which are demarcated to be areas of high probability, but they do not have an ore body now. So, these possibly the areas which can be selected for further intense ground exploration work, as we have seen in the case studies which we discussed before. Whether it is a thing we are doing by a mineral potential mapping and then coming out to the to selecting a high probable area, this situation is the same, that in this synthesis what we have done here, that we have used more varied type of information, geological, as we saw from the occurrence of a particular rock type, structural, geochemical and also geophysical. By integration of all these data, what and then associating that with the presence or absence of an ore body in that particular region, gives us regions which look to be further potential in terms of occurrence of the ore body, and those areas could be taken up for further exercise. So, this exercise, which is a mineral potential mapping, is basically done as a pre-exploration exercise and would minimize or would definitely optimize a lot of the cost factor in actually making many such unsuccessful intense ground exploration or prospecting work. I will just I will just finish the discussion in with the example of a bit of a, of course, even though it is not a very successful as it proved successful exploration effort, or it just could be looked at from academic point of view. This map of Hattimaski schist belt was earlier shown, and where the presently active, these are the presently productive areas like Hatti, Hirabudni and Uti, and the other ones like with the small bodies over here still are the prospects, and this is the entire Hattimaski schist belt, which is one of the schist belts occurring in the Dharwar Craton like many other auriferous schist belts. Situation is that in this entire schist belt only there are a very few working mine, or the presence of the ore body is known so far. So, let us see what we could So, this is the example that the Hatti group of rock could be shown here, and here it works as a binary theme in the sense that whatever area is shown in green, the presence of the Hatti group of rock will be considered as the feature being present or the value being 1 and the rest the value being 0. And similarly, the occurrence of the one of the phases of granite, the cavital granite is shown here. This is for the other phase of granite, and this is a example structural map which was produced long back. The structural map has got the F1 fold traces, F2 fold trace, the fault, and the various structural elements which are present here. Now, this particular qualitative map could be converted into a quantitative one by the process, the same process that was discussed, that by dividing the area into as many number of small cells as present and see whether a particular feature is present or absent in terms of an F1 fold axis or F2 fold axis, and this is the example in which such kind of structural elements have been picked up and are presented in the form of evidence in exactly the same way that whatever has been shown by these green thick lines are the points on which this feature is existing, and the rest of the area the feature is not existing. Similarly, this was the F1 anticlinal axis, these are the traces of the faults, and suppose this work this area was subjected to or was some geochemical studies, geochemical anomaly, geochemical dispersion pattern, and arsenic and antimony were measured in the soils of the entire area. And then this is could be a choice that let us see what are the areas where the arsenic is less than 1 parts per billion, or the areas which are between 1 to 12 parts per billion or more than 12 parts per billion. It could be one could choose could have a basis of this and can also have similar patterns generated. And a part of the area where the aeromagnetic anomaly map was available. So, that geomagnetic and the airborne magnetic anomaly map was the data was reduced and the surface it was projected to the surface, and this kind of a surface geochemical anomaly map could be produced for this area, which is true for only the upper half of the area. That also, since these are also numerical values, we could also discretize that and could divide them into regions in terms of the several limits or the several ranges of the geomagnetic aeromagnetic anomaly map, and could also integrate it as one of the layers, and then we integrate them all and find out something which is a gold potential map by using the calculation of the posterior probability by using the weight of evidence, and also similarly the same thing could be done by using a logistic regression, where our as we just introduced, that is a situation in which the dependent variable is representing two states, whether present or absent, not getting into much details of the analysis, and this kind of a mineral potential map could be produced. Here the values of course are pretty high, 0.85 to 0.99, maybe the way it has been scaled, and this also can be validated by the showing the areas in dark red or dark orange showing the highest potential, and then seeing actually whether the working mines are falling on them. That gives us some amount of confidence, and then these areas could be the areas where the probability of occurrence of this gold deposit are now presented to be high, and that could possibly be examined with respect to other features, because such kind of a map also could be prepared by taking the digital image images that are prepared by analyzing the digital image data in various ways, production of hydrothermal alteration zone or the lithology and many other structural features like in the case studies we discussed before, and further areas could be pinpointed for more intense ground exploration work. So, in such kind of exercise which is just given as an example, is not a successful exploration history. So, such kind of exercise depends on the accuracy of the input data that is being taken in, the satellite image data or the other kind of data of course, and the geophysical anomaly data as they have been interpreted, and depending on the method that has been applied. But then since they are being taken as input data, the accuracy of the data is very essential. These techniques are promising, and the accuracy are checked by the already productive locations, and so these are these methods are they have got ample potentials to be applied in the Indian situation, and they are being very routinely applied in many parts of the world. To conclude the discussion on the mineral exploration and the case histories, it can only be told that there are many more the present day, there are many new developed techniques which have come up, and mineral exploration now being told in terms of prospectivity or favorability analysis, and using all the techniques of spatial data modeling, which one can learn at the higher stages. Thank you very much.